this is Vinay. I am explaining the second question of homework 8 of probability and stochastic processes class of Professor Chen. So here given the n is given as Poisson process with parameter lambda, and the Poisson equation for this is n the number of random points arrive in time interval t1 to t2 is equal to k. So the equation, this Poisson's equation, e to the power minus lambda t2 minus t1 into lambda t1 t2 minus t1 to the power k divided by k factorial. So the stochastic equations first, and the stochastic processes xt is given as 1 when n, and where n is odd, when n is odd in the interval 0 to t, and xt equal to minus 1 when n is even in interval 0 to t. So in the part A we are and the stochastic process is the graph for the stochastic process is given as it varies from 1 to minus 1. So now in the part A we need to calculate probability of xt is equal to 1. So first simplifying our calculations, so e to the power lambda t is a standard series in this form. Similarly, e to the power lambda t is the standard series of this form, and if we subtract 1 from 2 we will get this, the only the odd powers of over lambda t will remain. So taking lambda common from this side and multiplying on this side, it will be 1 minus lambda e to the power minus 2 lambda t divided by 2 from LHS to RHS, and so the remaining equation will be this left hand side is equal to e to the power minus lambda t plus lambda t cube by 3 factorial, so on. Now probability of xt is equal to 1 is probability in interval 0 to t. K is odd as for this stochastic process. N is odd in interval 0 to t. So and for this will be given as k is equal to odd e to the power minus lambda t to the expanding this equation e to the power minus lambda t plus lambda t, so on. So this is equal to the simplified equation we derived here by subtraction e to the power lambda t minus e to the power minus lambda t, and this infinite series is simply equal to 1 minus e to the power minus 2 lambda t divided by 2. So this will be equal to this, and this is the answer. Now for part B we need to find mean of function xt, stochastic process xt. So again for simplification we will add two infinite series e to the power lambda t plus e to the power minus lambda t, and we will get even powers over lambda t. So again taking lambda t common on a LHS side, multiplying it to RHS and taking 2 from RHS to LHS, we will have e to the power minus lambda t into infinite series 1 plus lambda t square by 2 factorial, so on, is equal to 1 plus e to the power minus 2 lambda t divided by 2. So now probability of xt is equal to minus 1 according to xt stochastic process is when probability in interval 0 to t k is even. So for this process from above 1 plus 2, this will be equal to this. Now we need to find mean function of xt. So this will be equal to plus 1 into probability when xt is equal to 1 plus minus 1 into probability when xt is equal to minus 1. Plugging in the values we derived above, we get e to the power minus lambda 2 as mean function of xt. Now in the part D we need to evaluate whether xt is a wide sense stationary process or not. So we consider, let's consider that t2 is greater than t1. In this case there can be two cases, that both are positive and or both are negative, t1 and t2 lies in the negative region, or one is negative and another is positive, so we get two cases, equal to 1 and equal to minus 1. So considering both the cases, the autocorrelation function rt1t2 is equal to e xt1 into xt2. So this will be equal to plus 1, xt1 into xt2 is equal to 1 considering this process, or minus 1 into p xt1 into t2 into minus 1 the second process. Simplifying this, so this is when k is equal to a1, the standard stochastic processes of xt as given, and when this is k equal to odd, plugging in the values we derived in the part a and b, we get autocorrelation function rt1 t2 is equal to e to the power minus 2 lambda t2 minus t1. So this is for the case when t2 is greater than t1. When t1 will be greater than t2, the final result, that is e to the power minus 2 lambda and here it will only change that t1 minus t2. So we can write it as the generalization can be done as mod of t1 minus t2.